Yeah. So just a little bit about myself. Yeah, I'm Zoe, and I am right now getting my PhD in stats at UC Berkeley. Hopefully, I'll be done this summer, although it's kind of up in the air. Um, yeah, I really like to play and watch sports, particularly basketball, but all sports, and I love to bake. Um,
Great
yeah.
British, is
Oh,
it
go ahead.
Great British Baking Show? Do you watch that show?
Oh, yeah, yeah. I
Okay,
like
good, good.
reality TV a lot.
Okay.
And yeah, in terms of my favorite teams, I mean, I like watching a lot of sports, like the NFL, the NBA, college basketball, college football, but I love everything UNC. So anytime there's a UNC player like on an NFL or NBA team, that's probably the team I'm rooting for. And any UNC sport there is. And oh, actually my shirt right now, well, you probably can't see it, but I, this year Winthrop men's basketball is really good, and that's where I went before I went to WashU. So I'm rooting for them. They're undefeated. Maybe they will
Awesome.
be ranked soon. Yeah,
Oh, very cool.
yeah.
I'm like
Okay.
everything
So
UNC. So I gotta just,
yeah.
everything UNC always reminds me of She's the Man, because that's where she wants to go and play soccer as a soccer
Oh yeah.
player. So I know that UNC has a really good women's soccer team.
Yes. Like the probably like one of the best sports dynasties ever. They won like 20 of I don't know, like probably 25 national championships for in the 80s and 90s. Well, maybe in the early 2000s too. Yeah. They're really good.
Awesome.
And like the US women's national team, soccer team always has like 6 girls who played at UNC. So
Yeah, like I think yeah, I can't remember a couple of them off the top of my head, but I feel like it's always UNC. And I
yeah,
always just think that they have the powder blue uniforms and all those different like
yeah,
indicators. Like best brand management of all time, I feel like is UNC.
yeah. Like also like the best women's soccer player ever, maybe Mia Hamm was UNC,
Yes,
and Michael Jordan, obviously. So
of
it's a good
course.
school to be a fan of. Yeah, I grew up in Chapel Hill, so that's part of
Oh,
why.
awesome.
Yeah.
Very cool.
Okay. Yeah. So what I'm going to talk about today is when probability models, particularly in women's college basketball. So I've been making this model for this women's or it's not just college basketball, but women's basketball stats website called Her Hoop Stats. And it's kind of like Ken Palm, but for women's basketball and the NBA. So I'm just gonna walk through the modeling process and some of the results and also a little bit of the motivation for why we wanted to do it.
So is this real quick before we go into is this where you've like did they contract you to do this, or did you reach out to them to see if you could do this, or like what kind of created that relationship?
Oh, yeah. So when I did a research, or not really a research project, but I just made a Shiny app comparing the NBA and the WNBA. And after that, um, Aaron, who is the guy who runs Her Hoop Stats, just reached out to me. He got my email from somebody on Twitter or something like that. Um,
Wow.
and then I just started working on it, but it's pretty much volunteer. It's
For now.
yeah, maybe. Yeah, hopefully. Yeah, yeah. He hopes it can become a full-fledged, business where he can pay people, but at this point, it's not there yet.
That's cool though. It all came through Twitter and something that you had done kind of in your free time
Yeah,
amounted to you having this opportunity. So awesome.
yeah, yeah. I mean, if anybody is interested in women's basketball, he would happily have you help, I'm sure. Um, okay, yeah. So basically, you know, today is kind of the one of the a sort of perfect time to talk about this in-game probability model. So I'm actually just making a pre-game probability model, so sort of trying to predict the starting point of these in-game models. Eventually I hope I can move it to becoming an in-game probability model. But basically these models are tracking what's the chance that one team is going to win as the game progresses. And one really famous example is the Super Bowl, where the Patriots just made a really sort of improbable comeback at the end. And these are just a bunch of different win probability models tracking that game. And you can see there's some variability in what these models say is the chance that the Patriots are going to win. which was, sort of near zero. And then at the end, they ended up winning. So that there's like this nice summary of all these NFL models that this picture's from. And that the like name of that article is like all models are wrong, but some are useful. And that's like a, pretty famous stats quote, I think, from George Box. All these models are not like the exact probability that the Patriots are going to win. We can see that there's a lot of variability in what the models are predicting, but maybe some of them are useful for making sort of decisions in game. Like today in the game, NFL game earlier, like should Green Bay have gone for it on fourth down when they had the ball with just a little over 2 minutes left, down 8, and they decided to kick a field goal. I mean, intuitively, when I was watching the game, felt like they should have gone for it. But I think some of these win probability models actually said that they had a better chance to win if they kicked that field goal, because considering the chance of like making the 2-point conversion and going into overtime, the adding up all of those different sort of like things that could happen in the game, they actually maybe had a slightly better chance by kicking the field goal. Now, I think that the probabilities were really close, and maybe some models would say they had they had less of a chance by kicking the field goal, but some said that they had a greater chance. So like, I think that these kind of models do have some potential to be useful in making like an in-game decision making. It's a little easier in football because there's sort of more discrete things happening than in basketball, but it's possible that these could like help you make some decisions in basketball. A lot of these models are based off of like betting odds during the game, and that's something that we don't really have in women's college basketball. And so because like people, it's not really like a robust betting market. There's not a lot of people that bet on women's basketball. So there's not even like lines for most of the regular season women's basketball, college basketball games. So particularly people aren't betting like in game on these things. So
Yeah.
that does make this problem a little harder, but also makes for some opportunity. Like if you have a good win probability model, or a model that can predict like the spread of a game or the over under, then maybe because these markets aren't that robust, you could have the chance to make some money on it. And that's sort of what the motivation for this project for Aaron was, that hopefully by having some useful information for bettors on the website, he could get, more people to subscribe.
Yeah, no, it's interesting because like even before like betting was legal, I remember that someone was talking about how if you actually really wanted to get into betting, the one sport you should do is the WNBA, because there was very little strength in what lines they set initially on any given game. And that was where it was almost like the best ROI on a small bet, because anything could happen for the most part because people just don't know it well enough. Whereas you have people who have been watching men's basketball for decades who are helping establish what those lines are and kind of what the player performance will be, and what the impact is if someone's off the field or off the court or something along those lines, right?
Yeah.
And it's interesting that like women's basketball is almost just sitting there waiting for someone to do something like this to help out, in kind of someone like a bettor to be like, hey, why would I want to watch this more?
Yeah, yeah. No, I think that's definitely true. Like I said, I don't understand a ton about like how lines, are created and move around and stuff, but that is definitely like the motivation for this, is that there is some maybe opportunity to like make some money betting. And if you have a good model, then maybe that's where this like pregame win probability is useful. Um,
Awesome.
Okay, yeah. So just like I said, I'm doing this in women's college basketball. It is a slightly like more predictable thing than the men's game. Just like one example about that is, in men's college basketball, like nobody's gone undefeated for many, many years, but in women's college basketball, it's not that uncommon that there's an undefeated team, and like the last one was in 2015-16. So there is like less parity in women's basketball than there is in men's, but I do think it's actually uh, becoming more parity. Although I tried to like see if I could find any stats that would sort of back that up, and it just didn't really seem like that was the case. But I do think like the good players are a little more spread out than they
Mhm.
used to be. And it's not like UConn has not won since 2015-16. So it's not like the same team is actually just winning year after year after year.
And I'd say that, like, even in the last couple of years is the first time that I felt like I was watching women's basketball, like, especially the Final Four, because it had the most competition, like way more competition than some of the other stuff. I remember like Dak Prescott was at the game for Mississippi State here in Dallas when that game was happening, and like
Mhm.
it because of the upsets against like UConn primarily, it was where almost everybody started deciding to watch and say, "Hey, this has as much energy as March Madness for the male counterpart."
Yeah, yeah. I mean, and part of the fun of like March Madness is the upsets and on both sides. So I think that's definitely true. It's more fun when more teams are good. Um, yeah, and I mean, I love basketball, so I think women's basketball is really fun to watch just because it's basketball. But
Yeah.
obviously, it is a little bit of a different game than men's basketball. Okay. Yeah, so just like quickly what this her hoop stat website is like it's pretty similar to Ken Palm. If you guys have looked on Ken Palm, basically like we have for there's all kinds of different things, but for like a given game, Louisville's next game is against Miami, and Louisville's the number one team in the country right now. um they're really fun to watch, I think. And so basically, it'll just like give all kinds of different stats about these teams, their points per game, opponents' points per game, but also like sort of more advanced stats, which maybe I didn't get on this screenshot. Well, like points per 100 possessions, that kind of thing. So yeah, so anyway, it just provides like different information for women's basketball fans, or maybe like college basketball teams. Some subscribe to this website. You can do things like look up when's the last time somebody had, a certain stat line, if that's something you think is cool. Yeah. And it does this for the WNBA too. So basically the goal is to like get something like this that Ken Palm has. So this is Gonzaga's schedule for the year. All the games in green are the ones they played. And then of course, once the results happens, like that's the actual result. But before the game has happened, he has like a prediction of what the score will be and what's the probability that Gonzaga will win that game. And so like our goal is to basically make something like this for this her hoop stats website. Okay. Yeah, so just quickly to get into like the my sort of like process of how I did this modeling. I tried a bunch of different sort of like standard machine learning models, Ridge, Lasso, which are like linear models with some penalty so that you can fit models with a bunch of predictors, and then random forest and XGBoost, which allow for sort of more interactions between the data. And in all of these models, I like let there be either only first order terms, so only like the predictors themselves. I also fit the models with second order terms, so like all the predictors squared, or like all the different multiplications, so like games played times winning percentage or something like that. Yeah, so I trained all these different models and basically just compared them via this five-fold cross validation, and I have 5 years of data, but I'm only training it on 4 years because I'm going to use the previous season statistics to help predict the current season. So I'm just using these 4 years to do the training. So I mean, yeah, I'm kind of glossing over this. If people don't really know a bunch about training machine learning models, I guess I could talk about that in a future webinar if that's something that people are interested in.
Can you give a 20-second explanation of XGBoost? I haven't heard of XGBoost before. Can you just give a 20-second explanation?
Yeah, so I'm not sure if I'll do a good job of this, but it is like it's a decision tree, but in each time each time you fit the decision tree, it basically figures out so it like splits the data, you fit the decision tree, and it figures out which predictions you messed up, and then it'll like fit a new tree to try to fix the issues from the previous tree. So basically it'll just like iteratively do this thing where it's trying to learn the things that it messed up on in the previous iteration. Cool. So so the way I did this, because Aaron and I really wanted to like figure out sort of what stats were, actually important and to sort of keep the model relatively interpretable. I like sequentially tried models that included only these basic, like just basic stats of the win percentages of the two teams before the game and whether it was a neutral site game. And then I fit a model that had these basic stats plus these offensive, defensive, and net rating stats, which I'm gonna just describe on the next page, as well as then like a model with all those two plus the previous seasons, etc. So basically just to get an idea if like we were actually increasing our predictive power by including these stats. If we weren't, then we would like kind of stop and not include those in the model. Okay, so just quickly, so that people just understand what the stats I'm including are, the offensive rating is basically just like the points you score per 100 possessions. So instead of just being points per game, which obviously is like, if teams just don't, just are really like play a very slow pace, then they're not going to score that many points, but it might be that they're still a really good offense because they're very efficient about scoring points on their possessions. Then defensive rating is just the same thing, but with defense. So the number of points that your opponent scored divided by the number of possessions your opponents had up to that point. So all these stats will like compute before the game started. What's, if UNC is playing Duke, like what's UNC's offensive rating before the game and what's Duke's offensive rating before the game. And then the net rating is just your offensive rating minus your defensive rating. So if you have a positive net rating, then you're better on offense, or sorry, you're better on offense than defense. Okay, so so then the other set of statistics that I'm going to use is like strength of schedule statistics. So basically these stats are like before the game started, what's UNC's like average opponent up to that point, or their opponent's average winning percentage. Sorry, I think the average should be actually after. But anyway, so just to give an example, because this can be a little bit confusing, like one of the first marquee game of the women's basketball season was NC State against South Carolina. So NC State's undefeated. They're like the second ranked team in the country, and South Carolina, I can't remember what their ranking is, but I don't think they've lost since they played NC State. So they played each other on December 3rd. And before that game, NC State had only played North Florida and NC Central. So North Florida at the time on like December 3rd was 0-3, and NC Central on December 3rd was 1-1. So then this like average opponent winning percentage is just the average of like 0 and 0.5. And so we do this for offensive, defensive net ratings, as well as the winning percentage. And it just gives us an idea of like how good were the teams that NC State played prior to the game. So obviously early on in the season, it maybe doesn't provide that much information, but later on in the season, it could help like differentiate between a team like NC State and maybe a team that's in like a mid-major conference and has won a bunch of games and like kind of killed their conference, but actually they've just played a bunch of teams that are bad.
Is this metric, is this something that you developed of strength of schedule, or is it something that could be applied to other sports and things along those lines? Or
I think it's really similar to like how, I don't know, like I know it's similar to how the RPI was developed, so I think it's probably similar to like the net rating that they use for the NCAA tournament now. But I think this is like a pretty common way to like come up with strength of schedule. And I know that like Aaron mentioned to me that actually doing like the opponent winning percentage kind of thing, so like taking this one level further also usually does help. And I think that's what the net rating might do.
because you think about it, like with basketball, you have so many games, so something like this can just show so much, probably more strength throughout the season, right? Because like you said, beginning of the season versus the end. But in other sports where there are fewer head-to-heads, like football or something like that, and they usually have these really weak teams at the start for the most part, just I'm from Montana, so most of the people played Montana State where just to get an easy win, and then I
Yeah.
went to Rice and they played Rice just to get an easy win. So it's just the difference, and it usually was in those first couple games of the season. But basketball, because there are so many games, this metric is really interesting, because it almost tells a story throughout the season as compared to just kind of is just a number.
Yeah, yeah. I mean, in football, I guess sometimes like the very first game of the season, they'll have like, I don't know, a lot of times UNC plays against some SEC team like the first game of the season in like the in Atlanta or something like that. So those kind of games, like maybe that would help you sort of a couple games into the season if you know that, a team has already played a good team. But yeah, I agree. It's like it's not that useful at the beginning of the season. And so in football, maybe not that useful, but I do actually include like the previous season opponent average winning percentage. So then in that way, like you would differentiate between sort of like power conferences and mid-major because, if you're playing in the SEC, your previous season is going to have a pretty high strength of schedule
And
versus
this might be a dumb question, but does women's basketball, like NCAA, does it have the one and done like qualifications like men's?
Oh, no. So the rules for going to the WNBA, it's an age limit. Basically, almost everybody has to play all 4 years to be eligible, but there are some people, if they, like, start a little, like, if they're a little older, then they can be eligible after 3 years. But, most people play all 4 years.
So that would
Yeah,
make the previous schedule though probably more important in this kind of in
yeah.
women's basketball compared to
Yeah,
men's.
one thing that like I definitely want to include, but it's just I don't have the data for it yet, is like the percentage of minutes returning or percentage of points returning, which would be more useful, yeah, for something like men's basketball, where I think this season at least the young teams are doing quite poorly. So yeah, definitely helps to have some experience. But in women's basketball, most teams are fairly experienced. Okay. Yeah, so this table's not that interesting, but just basically like I fit these models, like I said, just like the basic stats plus the rating, etc. And I used log loss to train, which essentially like instead of because we're classifying, right, like win or lose, but when you make these classifications, you're actually like saying the probability of a win or probability of a loss, and negative log loss, like it basically uses those probabilities instead of just using like whether you predicted win or lose. And so it's definitely like it's what people use to train like neural networks and stuff. I'm not sure it's really like that important to use here, but it's what I think it is a good loss to use when you train machine learning models. But basically, the point of this is like I didn't train any XGBoost or random forest for the fourth model because like Lasso and Ridge were always better. So this is just picking the best of Lasso and Ridge. Usually Lasso's better, and like with including the second order stats, so including like the squared and interacting terms as well. So yeah, basically the point is like this fourth model with all the stats is closest to 0 and has the highest ROC, so it's the best model. So that's what I'm going to look at like some figures of next. Yeah, so just comparing like how much we improve from just like using this basic information to using all the statistics. On the x-axis here, we have like the percentage of like true observed wins. So like at 0.25, that means like people here won 25% of the time versus like we actually predicted that they would win 25%. So I'm just like binning the games up on the x-axis and then computing like the percentage of wins in those bins. So we can see the red is like that you've played 0 to 7 games, and we do the worst job of predicting the red. And yeah, so the win probability is always for the home team. So like a win probability of 1 means we predict the home team wins 1% of the time, or 100% of the time, sorry. And yeah, we do get better like towards the green, but obviously you can see like all the lines here are closer to like the y equals x line, which means we would be doing like perfect predictions essentially. So yeah, basically like adding these additional models gets us we do a pretty good job, but for some reason we always sort of seem to be like underestimating the home winning percentage. So like when the home team actually wins 25% of the time, for some reason we're predicting that they win slightly less than 25% of the time. So that's something that I am going to try to figure out why it's happening. Yeah, just this plot's not that pretty. I didn't have time to like fix the labels here, so sorry about that. But just like I just wanted to show what the important predictors are. Like they make sense. Basically, like before the game, the net rating of the home and the away team are like the most important things to know. And if the net rating of the away team is large, then we're gonna like predict more likely that the away team wins than the home team. And then, this is like one of the strength of schedule stats. This is like the previous season strength of schedule stat. And these are, yeah, some more, basically a lot of the previous season and strength of schedule stats end up being pretty important to like the predicting who wins the game or not.
Right. That's really, I mean, even just that visual, you explaining kind of what those mean, it makes sense because the previous season, especially given what we know now that most players are coming back as well, would be where that's a really strong indication of how that team would perform in a home
Yeah,
game
I
of
think it
season.
just kind of like uh I mean, this is like a very statistical term, but I think it kind of like does a little bit of shrinkage, sort of like, especially early on in the season, um, is like you you have some, like some team just happen to play like amazing in the first 3 games of the season. But like they're really not that great, that like if they didn't do well the previous season, it'll kind of like pull them back to the mean a little bit. So I think there's that sort of part of why it's helpful. But yeah, it's particularly helpful, in these like early season game, like these red games where like we just wouldn't know anything about how good these teams are before we sort of add this previous season information. And yeah, we have played around a little bit with like using some kind of like decay to get rid of the previous season stats towards the end. And it doesn't really like change the model. It still kind of works very similarly, because a lot, these are only the top 10, but some of the other ones, like one of the top terms that it's not shown is like the games played times the previous season stat. So like that kind of is the interaction term that like maybe takes care of the fact that by the end of the season you don't want to weight the previous season as much. Okay. Yeah. So I also, in addition to like, I've been talking about win probability models, but I also did like score prediction. So I did like joint prediction task on the score for the home team and the score for the away team, to then, like it for betting purposes, it would be like to get the spread or to get the like over under on the game. And so, yeah, I mean, if we were predicting perfectly, right, we'd be like right along this y equals x line in both cases. This side is the spread, the score differential, and this side is the score total. And, we seem to be sort of doing better, especially for the score differential. The like darker points here are the games that were early in the season. And we seem to kind of, I don't know, be messing up a little bit on those games. Well, maybe not that much, but anyway, including if we don't include the previous season stats, like we actually do really bad on the, I don't have this figure, but really bad on the early games. So yeah, it seems like we are kind of doing a good job of predicting the spread over these 4 seasons, and a slightly worse job of predicting the over under. That seems like a harder problem. And it sort of seems like for whatever reason, we should be like, yeah, this whole cloud of points should be shifted. Like somehow the model should learn that it's doing a bad job up here, and it's not. And I think it's because actually in this like kind of middle area, it is fitting the right line. So I'm thinking that I might need to, I only tried this with linear models, so I might need to try it with like a non-linear model. Okay. And yeah, so then just like one thing that I wanted to check was like, do the predictions match each other? Do the estimated win probability and the estimated spread here actually make sense, right? Because like it wouldn't be good if when we were predicting that a team wins 75% of the time, that we're actually also predicting that they like have a spread of -20, or that they, that they lose by 25, which seems to be actually kind of happening in some of these points in the early season games, that we predict like that the win probability is 25%, but then we actually predict that that same team wins by 10 points or something. So that's a bit of a problem that I'll need to figure out. But yeah, we can see like the lighter points in the middle here are sort of like tighter together, and the darker points, the games that are earlier on, we have a slightly different prediction for whatever reason for the spread and the win probability.
Yeah, no, I think in this visual, you can definitely tell that the darker games are the ones that are further away from the line as
Yeah,
compared to the later ones. Because even this is probably the one graph that makes I can see the light yellow even in it. And
yeah,
so that kind of really does seem almost like a jawbreaker in a way, like
yeah,
color wise.
yeah. No, this is definitely, I actually like just fit these models the other day, so I need to think a little bit more. I think I was going to touch on this on the last side, but I think I should probably like do a multitask prediction. I'm already doing the multitask prediction for like the home and the away team, but it would make sense to do a multitask prediction with like the win probability and the home and the away team, because that way you would think the model should be able to learn that every time that it predicts a win, it should never predict a spread above or below 0. Yeah. Okay, yeah. So just like quickly to zoom in on the games that we actually messed up on, which like I'm sort of belaboring the same point I made before, but we can see the games that we like really mess up on. So essentially I'm looking at the places where the win probability was less than 0.5, but we predict like a spread above 0. And then the games where the win probability is greater than 0.5, but we predict that the home team actually loses by some number. And we can see that, yeah, like the darker points are the ones that are really far away. Like this is a terrible one where we're predicting like this team almost never wins, yet we predict they win by a couple points. So but yeah, essentially if you like go to about 20 games or so, like there's almost no points left on this plot, and the points that are left are like win probabilities between like 0.45 and 0.55, and the spreads are also very small. So that's a little bit of inconsistency, but not like something to really fret about. Yeah, okay. So that's sort of the gist of what I've done so far. Like I said, I want to try to get rid of these discrepancies between like when we predict a win, but we actually don't predict the team wins based on the score. And I do want to add some additional predictors, like I pointed out about, maybe adding stuff about like the percentage of points returning, that kind of thing. Um, and then eventually convert it to an end game probability model, and maybe like you could use it to answer some interesting basketball questions, like when should we start fouling if we're down at the end, and like is that if we have a really like complicated model, you could maybe sort of try to figure out like based on who's on the floor, like if LeBron's on the floor or something, should that change our strategy? I mean, I don't know if you could actually like fit a model that would be able to really predict all these things. I mean, like back to the things like all models are wrong. So I'm somewhat skeptical of like how complicated you could make it, but I do think it's possible that you could use these models to answer somewhat interesting questions. And like even if it's not an end game model, but you include sort of more predictors about the players to just predict like, I don't know, at the beginning of the season, how good will some random team be, that may provide some useful information.
Zoe, you know what I'm thinking there too would be a good addition would be like the home and away. I'm always curious about predictors based on like if it's a home game versus an away game, adding that
Yeah,
kind of factor in
yeah,
there.
so that I glossed over that, but that is included.
Oh,
Basically, I'm
nice.
always predicting like the home team winning percentage, but then I have an
Gotcha.
indicator of whether it's a neutral site game. So like that should effectively deal with it. So basically, like if I look at the basically when everything's zero except when everything's zero, we're predicting the home team wins like 75% of the time or something.
Gotcha. Quick one with that. Did you do any sort of like feature ranking with that? Like, are there any sort of other features that are prioritized or anything like that?
Yeah, so that's kind of what this plot is. Like
Gotcha.
that
Okay. That's what I figured as
the
well.
net rating or is basically the most important thing. I don't have these for I don't have these in the slides for these models, but for these it's like the offensive rating of the home team and the defensive rating of the away team are for the home score is the most important, and then for the away score it's like the opposite.
Nice. Oh.
Yeah.
So I've got a quick question about March Madness, more or less, because I feel like, and this is something that Avi and I were kind of talking about, where is there a reality to the idea that we can predict who's going to continue to progress well through March Madness? Or is it where marketing has literally convinced us that these upsets are so common that we should all just like bust our brackets and like try to guess all these upsets happening? Or
I mean, I think upsets are inevitable. I mean, there's like a lot of randomness, particularly I should reiterate, women's basketball is easier to model than men's basketball. I don't know what exactly like this would look like, but I'm assuming I would do much worse in men's basketball. Yeah, I mean, I think predicting the NCAA tournament is like you maybe would give yourself a good shot to like, do relatively well in a like bracket pool or something, but it's never going to like tell you how to get the perfect bracket, right? Because like sometimes there's going to be an upset and like that's just how it is.
I want that $1 billion that Warren Buffett always offers, right? Like the
Yeah.
perfect bracket. Everyone always going for that. So cool.
Hey Zoe, I thought this was really interesting. One question I had was, did you do any modeling between like if you have an opponent in a given team, modeling between their stats? Like for example, if you took like home team's offensive rebounding and then the away team's defensive rebounding, and looking at like strength on one side versus a weakness on the other. Like, is there any interaction between stats on multiple teams when they're playing each other?
Yeah, those don't like come up as like super important predictors in the model. Like they're never one of the like top predictors. I should look more carefully. Like I said, I just made these models, so I didn't really look carefully at what predictors were important, but it's possible that here like the interaction between like the offensive rating for the home team and the defensive rating for the away team does, is one of the most important things. It's not something I looked at super carefully though.
Gotcha.
I didn't mean to cut you off as well, Zoe. I think you had one more bullet there. I don't know if you wanted to close it out with that.
Oh, no, I think I
Oh, you finished.
touched on that. Yeah. Basically just asking the question of like if we could use these models to answer sort of like strategy questions like people do in football.
Yeah.
I don't know if it's possible, but it's something to think about.
So you open sourcing this code or what?
I mean, it's not, I would have to ask Aaron from like the Her Hoop stats. I'm happy to share the code. I don't know if he really is happy to share the data though.
Yeah, you wrote this all in Python, I assume.
Yes, yeah.
Nice. Yeah, we're doing some modeling for some colleges as well on the men's side, and just kind of curious how this would translate into that. I don't know if Andrew, Blake, Omar, if you guys want to speak up on anything about if you could see any translations into there as well.
I mean, it'd certainly be something interesting to if we could get it, pulled in. Like I think a lot of the reason I was asking even about like offensive rebounding on one team relative to defensive rebounding of an opponent is like, at least in our experience, some of the coaches have been like, they have very specific questions, right? Like they're not often going to ask like, what's our win percentage against this team going to be? Like, it's more, okay, if I run a slot pick and roll and the opposing team is going to ice it 80% of the time, how does that affect my points per possession? Like that kind of, it's always like really specific stuff, so it'd be interesting to take some of this, like just the concepts that you've got here too. And I mean, so obviously some of it doing it on like a macro scale, a lot of it's just data availability, like what you have you know, open to you. But it'd be interesting to take some of these same concepts and apply it to like really specific situations, you know, whether it's like pick and roll and counter calls to that, or, you know, different, like a horn set and how the defense aligns, you know, just different things like that. But like I said, I thought it was super interesting. Just
Yeah.
kind of seeing how you thought through it
No,
all.
that seems that, I mean, obviously, like, I it's not as interesting to be predicting just like whether a team wins or not, and I would be much more interested in answering questions that like are like that are related more to like the strategy of a game. But yeah, like you mentioned, of course, knowing when somebody like does a horn set, or when somebody, you know, when there's a pick and roll or whatever, is not data, at least that I have access to. So um,
And sorry,
but I
Blake, did you have something too? I didn't mean to interrupt.
Yeah, you made me forget it though. So I think I was just saying like kind of the whole process she was going through as far as translating this to men's. And the whole process would be the exact same, but like she said, I think there would be a lot more noise, really, and so it, you always see more dominant teams in women's sports, at least for my limited knowledge, and so I do think there would be a lot more noise trying to predict brackets.
yeah, definitely.
Yeah, I mean, if nothing else, I mean, Zoe, if you had, I know you probably got all on your plate here just with this, but I mean, at some point, if you had interest, like we, you know, at least for a few of these teams, we do have some of that more specific data. So if you wanted to take some of that and try to run with it, you know, and build out some kind of predictive model, you know, and it extends beyond just pick and roll calls. You know, I mean, there are a lot of other things kind of moving into it, but it gets really granular because some of these teams are gathering their own data, you know, and
Yeah.
they're gonna capture really specific stuff that no other data source would have, you know, like
Mhm.
even individual play calls and how exactly, you know, how the outcomes vary based on what they're calling and what the defense is doing. So anyways, if you had interest in it at some point, you know, like I said, I think you've got a lot of really cool like skills and tools, you know, available here that would be interesting to see applied to different data sets too.
Yeah, no, that sounds cool. I would be interested. I'm trying not to spread myself too thin because I want to finish school. But yeah, I'll let you know if I like feel like I have time.
Definitely. Well, like I said, I appreciate you doing this. I enjoyed listening to it.
Okay, cool. Thanks.
Yeah, this was great. Thanks.
Thank you.
All right. So Zoe, oh, you have to show your
Oh,
final slide. It says your Twitter on it, and it says
oh, whoops. My
your
bad.
GitHub, so people can find you and all the information about you. Oh, you
I
can't.
think I follow
Don't
you
worry
on
about
GitHub
it.
already. I think.
Oh,
Yeah,
really?
that's how I think your first tweet had your GitHub that I
Oh,
found you through, and then I followed
my
you.
bad about the Twitter.
I'm gonna share it just so that way
Okay.
everyone can see it on my second desktop here. So what we got here? Yeah,
You can
so
also,
everyone can see that.
you can send a screenshot in the Slack maybe afterwards too.
Yeah, it's also just for the YouTube video. If people want to follow you on Twitter, I think that's also where they can find that article that you wrote on WNBA versus NBA,
Yeah.
correct? I liked how you had certain players, I mean, certain teams. If you like it on the NBA, you should look at them in the WNBA. It was a really catchy article. So everyone should try to find that. And then you have your GitHub right there. Thank you so much for joining us, Zoe, and taking time. You are probably one of the busiest people that have helped us out with this. So appreciate that. And if you ever want to come back and talk about kind of where this goes or other research you're doing, feel free to
Maybe summer.
use.
Maybe we could see
Yeah.
a summer presentation how this goes.
Yeah.
So.
Yeah.
Yeah, I mean, like in a way, the goal of this is to have an audience for you as well as having it be for us to learn from you. So if you just are like, hey, who can I bounce ideas off of? I think all of us here are trying to be that audience for each other. So
Okay. Yeah. Sounds
and
good.
if you really want to talk about Bachelor stuff, I got you. Okay. I got all the stuff on Bachelor and Bachelorette. So
Yeah, I'm sorry I missed that. But yeah, I do love The Bachelor. So
Avi, we gotta add her to our secret channel.
Thanks, Zoe.
All right.
Appreciate it.
Thank
Yeah,
you,
thanks
Zoe.
for having me.
Just to remind everybody, up next we have Avi talking about the age range in the NBA, and he has a Python that he's been working on with that. So that'll be next Sunday, and always you can find our schedules on Eventbrite. So thank you, and have a good night.
Take care.
Bye.